We're going to look at polynomial division, and usually use polynomial division to try to find factors. So this is a cubic function because it's to the power of 3. Okay? So a lot of the factoring methods that we use for quadratic functions or trinomials, they won't really work here. Okay, so we're kind of stuck. So what we're going to do is we try to find factors of it. And because we're trying to find zeros, essentially when you're looking for roots, it's not very straight, but if you're looking for roots, this is some cubic function, okay? And actually that'd be a negative cubic function. So let's try to keep this positive here. You're looking for a cubic function, and it possibly has 1, 2, 3 roots, okay? And those roots are when the y value is essentially at 0. So your f of x in this case can be replaced with the value of 0. Okay, so we're looking for some value of x. We need to find some value of x, so something that we can plug into here, that will essentially equal 0. So this is kind of a trial and error method. Okay, we need to trial and error our way through this in order to find it. The best values to trial and error are with your a term, so your leading coefficient, and whatever your constant is, we'll call it c. In this case, if you're go down alphabetically, be A, B, usually they call this C, but we're just going to call it C for constant, okay? So we look for the factors of that. Now, our A term in this case, there's nothing there, so it's the idea of just a value of 1, okay? So we're going to multiply -6 times 1, and since we're so good at math, we get it, it's -6. So now what we want to do is list a bunch of factors of -6. Well, the absolute values are 1 and 6 and 2 and 3. But then again, it could be +1 and -6, or -1 and +6, or vice versa, +2, -3, or +3 and -2. So all of these are factors. So not only are there 4 options, but there's ×2 because there's a plus and negative value. So what we're going to do is we're going to plug in those values into this function to see if any of them work. Okay? Is there a fast way to do this? I could do it with my calculator. Let's see if we can do this a quick way, if I can reduplicate stuff. So let's just go with the number 1, and that should be cubed. That doesn't quite look like cubed. There you go. Okay. Let's go, we know 1 cubed. I think I can actually do this by my hand much faster. 1 cubed is going to be just 1, okay? So let's do disappearing. 1 squared is 1 times 2 is 2, so we have 1 plus 2 minus 5 minus 6. That gives us 3, -2, -8. Okay, so +1 didn't work out. Okay, -1. -1 cubed, well, actually it gives me -1. -1 squared is +1, so +2. And then negative times negative is +5 minus 6. -1 and 2 is 1 plus 5 gives us 6 minus 6. That works out. Okay, I know I did that really quickly, but +1 works out. So in other words,
-1.
Oh, sorry, yeah, it's -1. So if I put in -1 here, we get -1 cubed plus 2 times -1 squared minus 5 times -1 minus 6. And actually work through this for you. So -1 plus 2 plus 5 minus 6, and we end up at the value of 0. Great. So what that means now is one of our factors is -1. So we're going to reverse engineer this. Normally we write a factor. That means that how am I going to write this? -1 equals 0. Yeah, x is equal to, that's how I want to write it, sorry, is equal to -1. But what we need to happen here is we need this to be like a 0 factor. So I'm going to move -1 to the other side. So we have x plus 1 equals 0. Okay, and now this is kind of a binomial we can use for division. So that's how we create the binomial. Okay, so now that's a lot of work just for that part. You'll eventually get really fast at that. We have x plus 1, and we're going to use, similar to long division, they call it like polynomial division, we're going to divide what we originally had as the polynomial. So x cubed plus 2x squared
minus 5x minus 6.
Beautiful. Minus 6. Great. So now what we do is the whole idea is to focus on the variables. Okay, they're the first term. So really this is going to deal with 2 terms at a time. Okay, but the whole goal is to eliminate the first terms in the binomials we're working with. Okay, so I need to multiply the x times something that will essentially eliminate this x cubed. In other words, I need to create an x cubed. So x times what is equal to x cubed? That's my question here.
X squared.
X squared, exactly, yeah. So my x squared goes here. And I actually think of like distributive property. I need to do x squared times both of these. So that gives us x cubed, and that gives us x squared. So that's what we're going to subtract by when we do this. So we subtract by x cubed plus x squared, okay? And now we subtract. This cancels out. And here, think of it like a coefficient of 1. 1 minus 2 gives you just x squared. Great. So now we bring down our next term, just like long division. So we have negative 5x. And then I repeat the exact same process. I need this x to multiply by something that will eliminate this x squared. And we know it needs to become x squared. So x times what is x squared?
X.
Yeah. And it's positive x, so plus x. Same idea again. We do like a distributive property, x times 1, and that gives us x squared plus x. Great. We subtract. These two cancel out. Negative 5 plus 1 gives us negative 4x. And then we bring down our negative 6 here. Did I do that right? Oh, I did it wrong. Good. It should be subtracting. Negative 5, yes, it should be 6. Good. And the reason I knew that is because I knew this was a factor, and what it's going to happen is there's going to be no remainders. And right away looking at that, I'm like, that's not going to work. We're not going to have no remainders. Good. Thank goodness I can't do normal subtraction. Okay, so we got negative 6 and negative 6x minus 6. And exact same idea as before. X times what equals negative 6? Well, exactly, negative 6. Same idea again. We take negative 6 and we kind of multiply it in like distributive property. And we're left with negative 6x minus 6. And lo and behold, we get no remainder. Great. So up on top is what's left when we divide by this. So I need to rewrite this function. I'm not technically done. I'm trying to factor. So f at x is equal to, this is a set. So we've taken x plus 1 out of the original polynomial. And what's left over is x squared plus x minus 6. X squared plus x minus 6. Now, we can repeat that entire process again for this, if we like. So that's like finding factors of negative 6 and 1 and plugging them in and then dividing. But there's something easier now. This is a trinomial, which we have some methods for factoring. Okay? I don't know if you remember your product sum. This is an a value of 1, so this one's actually really easy to factor. We don't have to do like decomposition or anything like that. We just need two numbers that multiply to negative 6 and add to positive 1. And I'm going to tell you that those are, if you remember your factoring, they'll be positive 3 and minus 2. And we bring down our other factor, x plus 1. And ba-boom, we have all of our x-intercepts. So not only have we gone from standard to now we're in factored form. Okay, so this is a factored form of that polynomial. We also can figure out all of the zeros. And we already knew one of them because we had to figure it out. We know that x was equal to negative 1. This x would be x is equal to negative 3. We just set the bracket equal to 0 and move it. You're okay with that?
Yeah.
Okay, and this x would be x is equal to positive 2. And we can check with our lovely graphing program just to prove it here. Here's our function. It's positively sloped. And we have one at negative 3, negative 1, and 2. Is that what we got? Negative 1, negative 3, 2. Perfect.
Yeah.
Okay.